Both of them became popular running together, the MapReduce running over the Hadoop system. So what is the MapReduce? It's a programming model for this distributed computing, and it was mainly designed for batch processing. So remember that this Hadoop system was designed for batch works, where we have one job coming in, then the next job, and the next job, and they're queued. And when the first one is done, the next one will run in the queue. So it works like a unique pipeline in a sense, because what it does, it takes an input, and then there is a map function. This map function will use key value pair and perform some computation on the input data. After the map function is done, we can shuffle or sort the results that it produced. And each one of these maps will run on a separate node in a mapper of its own. And when at the same time, so there is multiple mappers to run at the same time, and then shuffle and sort, and after their output is produced, they are given to reducers that run also on their own node. So the output of the mappers is given to the reducers as an input, and then the final output is produced of the whole system by the reducers. This is so for example, grep is a command that we can run for searching through text. Let's say you want to return all the lines of text that contain a particular keyword. So we can run this grep command, and if we do that, and there is some huge file, then each piece of the file will go into a separate mapper, and the grep will be looking through that part of the file for that word, for that keyword. Then it can maybe sort the number of times that it found it, or shuffle it, and the output will be given to the reducers. Maybe reducers can count the number of times that this word was found and show the output. So this type of pipeline model is efficient when we have to go through large amounts of data, and reduces the seek time. It is a good application for, let's say, if we want to search through some huge log file. Let's say there is a web server that produces a huge log file for all the users that browse web pages on that server. So it's going to have their IP address, the time they browsed the page, what page they browsed, which page they went to next, and all of that information in a log file, and that's huge. Because if it's a huge web server with users, imagine you probably cannot open that text file on a laptop because it's going to take several days. So in this kind of file, it will be efficient to process through that MapReduce function on the cluster. Same situation we have with index building for the web. All right, we have a lot of websites on the web. And if we are to create an index of which website contains a particular subject, then that also is appropriate for this MapReduce model. How does it work? As I mentioned, each of these mappers will run on a separate node. So there is an input data. These are the parts of the file. Each part is leading into a mapping process, so this is called a mapper. And the mapper will do some processing. Let's say it's searching for a particular word in the file. It will create some intermediate results. I found this word here on this one. I line or on the next line and the next line. The values or this intermediate data that is produced can be either shuffled or sorted. So if it's shuffled, it can go into random places for the reducers to take it as an input. So in another node, there will be reducer running, and this reducer takes the intermediate output from the network and does again some processing on it. Let's say this reducer might count the number of times that word was found. So that was in your sample program that I gave you. So we have this system with multiple nodes. They could be, as we said, hundreds of those nodes. And if the file is big enough, it's going to take literally hundreds of nodes to process it. And the beauty of this is that each node is running at the same time and does some processing on some parts of the data. And when 100 computers are processing some piece of the data at the same time, it'll get much faster processed than if it was on a single machine. Of course, we have issues with the performance of individual hard drives, and some of them failing at any time, and or having to transfer data from one node to another on the network, which is a very slow process compared to transferring data between your CPU and your hard drive. So when the data is to go on the network, it slows things down, and some of these links might be congested, introducing additional slowdown. So if this MapReduce, there are many iterations, so we have to go through the data many times, then it can significantly slow down performance. It is good for read the data once, do some processing, and produce the output. If it has to go and read data over and over again in some loop, then the performance will not be very good in this system. So fine-grained MapReduce tasks improve load balancing and faster recovery from failed tasks. So the Hadoop system is managing the nodes. If any of the nodes will fail, it will find the copies of the data that was supposed to be on these nodes and restart the processing on another node that has the copies of this data. So if a failure happens, there will be re-execution. We do, as we mentioned earlier, expect that some of those nodes might be slow or not performing well or fail altogether. If that is the case, then we will assign the execution to another node and re-execute. And also the Hadoop system is checking which of them have lots of load and which parts of the network are slow and congested. And so we'll do load balancing and recover from failed tasks. So bandwidth, that is again the amount of data that can be transferred per second on a particular network link. So the more data we have to transfer, the data is large, obviously it will be slow because it's going on the network. However, the distributed file system of Hadoop plus this MapReduce functionality together is an effective solution for this type of job batch processing jobs that will be done by Facebook and Google and companies like that just have humongous text files that they have to go through. So this type of model is efficient for them. So the MapReduce queries the distributed system for locations of the input data, and then a map tasks are scheduled on the machines that are close to where the data is located, if that's possible. So how does a mapper look like? It has input value, lines of text of input, value pairs because it takes value and a key. A key could be, so the value is some input, for example, and the key could be a word or some number, let's say 1. The reducer has to use the same key from the mapper. So the reducer will take the key as an input, and the key and value pair, and then will produce an output. Let's say it does the sum of the values. So it's going to take some word as a key, value is the count, the number of times that this word occurred in the text, and it will produce an output. Let's say it will add these counts together. That is what was in your program that I gave you. So the mapper will take the file, that's the value, key is particular word. The reducer will take the word as a key, and then it can count the number of times that it word occurs, so it's going to sum up the counts. So we have this program written. If we want to run it, then we have to create a job and submit this job to the cluster. Let's see an example of this word count program. So it takes as an input lines with words. In this case, these are the words: deer, deer, river, car, something else. This is the whole file. Now imagine this file is big, or there could be several files that come in together. And we will split that into pieces, and each piece goes into a mapper. The mapper will use key, value, pair. In this case, the key is deer and the value is 1. So there is a number of mappers as many as pieces we split the file into. Each mapper will get one piece. Then there is shuffling or sorting. In this case, because sorting because all the key named deer are together. All the deers are here, all the cars are here, and all the beers are here. And then these will be given to a reducer with their key value pair. And in our case, the word count program, the reducer took the key, the word, and the values and just added them together. So there was 2 here, 1 and 1, 2. Over here we will get 2 again. Just added them together. And then produced all the reducers. Their combined output is the word and the number of times that the word occurred.